Hey, and welcome back to another Learning Java 2D Game Programming video. So in our last video, we made some optimizations to our rendering. So what we did was we only render the things that we can see on screen. So we filter our game objects by our view bounds from our camera, and we do a similar thing to our map. So to our tiles, the game map, we gave it some safety space when rendering, so we're rendering a little bit outside our viewing bounds, and that's because of weird positions and sizes and things like that. So if a tile would start over here, then the entire tile would be black because top left corner is the position. So having some safety space is just needed. And I saw now that the same goes for our game objects. So you can see down here, they're sort of popping in and out of existence, and it's for the exact same reason. So let's just fix that first. Go to your camera. And here, when we're calculating our view bounds, we probably want to split this into several rows now because it's getting quite long. We want to add some extra space for the width and the height. So start by making a private static final int safety space. Let's make that 2 times game.sprite size. And let's add it to our width and our height. So safety space and safety space. And in here, we're not dealing with indexes, so we don't have to worry about an index out of bounds exception. So you can just do that and it'll be fine. And now you can see all these little heads and everything sticking up here. So that seemed to work out just fine. Awesome. After that, I have been Googling a little bit and I came across someone talking about buffers. So in the first episode, we made the frame, the window, and I set my buffer strategy to 3 buffers. But well, from what I've been reading, 3 buffers doesn't really do anything more than what 2 buffers do. So it doesn't add any value, but it adds work. So we're just going to set this to 2, and it's going to do basically the same thing. So it works the same, and there's no flickering. 2 buffers is enough. Our computers are fast enough. It's fine. And I get a small performance boost, so I guess it's always something. And now on to the thing that I wanted to do today. And I'm just quickly going to say what that is. So when we read our images from disk, they are stored in memory. And they can be stored in different formats in memory. So when you read it from the disk, it's not always in the most compatible format with your platform or your system, which means that if it's incompatible, it will be converted every time you render it, which means basically you render each image twice. Now, what I found when I tested this earlier was that on my system, it is the most compatible. So I didn't get any performance boost. It didn't matter that I did this conversion here, but it might matter to you, and it might matter to someone else who will be playing your game. So this is still an important step to do. We're gonna convert the image that we load into the most compatible format for the system that is running this code. So let's get to that. First of all, we don't want to return this anymore. Let's save it in image from disk. All right. And now I think we need a separate method. Let's make a public static image create compatible image, and let's take in a size and an int for the transparency mode. And I'll just talk a little bit about that in a second. So let's first of all get our graphics configuration, which we can get from our graphics environment, get local graphics environment, get default screen device, and get default configuration. So this, I guess, is a configuration for our screen device, which must be what outputs to our screen, I guess. What we can do now is return graphics configuration, create compatible image, and we want the width, we want the height, and we want the transparency mode. So transparency has different modes. Either there is no transparency, it's completely opaque. But as in the case for our sprites, they are bit masked, which means that a pixel can be either completely invisible or completely visible. And bit mask transparencies aren't very expensive. They're quite cheap. However, there's also the blend mode. If maybe you'd have like a ghost that it should be sort of see-through, that is very expensive, because that means that for every pixel it needs to calculate from the background that's already there with the pixel that you have and the value for its transparency, which could be anywhere from 0 to 1, right? So it needs to calculate for every pixel what the new value will be. So it's very expensive. Bit masking is not expensive. If you can see on the image that you're drawing that this should be completely visible, it just transfers that pixel. Or if it sees that this should be invisible, it does nothing. So that's why that's cheap. So keep your blending sprites or images down to a minimum. And that does not mean don't use them. It just means use them sparingly. Use them, know when and why, right? All right, so let's continue. Now that we have this method, let's get compatible image from create compatible image, and let's make a new size with the image from disk get width, and that takes an image from server, and we just put in null, and image from disk get height, put in null. This is getting very long, so let's put this maybe. Does that even help? So this also takes the transparency mode, and to keep track of them, I put them up here. Let's just duplicate that and say alpha bit masked. This will be 3, and this will be the alpha blend. So right now I'm saying for all of the images that I load in that they will be alpha bit masked. And there's something that I didn't do right. We just need to cast this to a buffered image. So now that we have this image, we need to transfer this image onto this image, of course. So we'll just paint it once. All right, we've done this before. All right, and this should be it. All right, and here we go. So as you can see, it didn't really do a whole lot of difference for me. but it might do a difference for you, and it might make a difference for someone who will be using your game. So this will be all for this video. Thank you for watching, and I'll see you soon. Hej då!